Morning, good evening, good afternoon. I see a lot of people joining in from very different location. Just a quick intro for myself. I'm Lavi. I work for Google. I'm ML engineer here. I work very closely with the developer advocacy team here at Google Cloud. I have been here a couple of times. I've given a couple of sessions here. Um, so happy to be back and happy to interact with a lot of folks. What you see right now on the screen is the two notebooks that we'll talk about today. I'll sort of go in detail of what essentially we're going to cover today, and feel free to post your questions on the chat. If something is very pertinent, make sure to raise your hand. I'll try to address it. I don't have the access to the chat in front of me right away, but I'll take a pause in between and I'll check all the questions. So, and I'll probably towards the end of the session, I'll keep it open. I'll stay back a little more than what the session is. So if you have any sort of bigger questions, something that you want to understand, we'll sort of go in detail towards the end. Having said that, let's sort of, again, I've shared the link of the notebook on the, oops, let me sort of share it across everyone. I've shared it on the group, on the chat, so you should all have access to the notebooks of what I'll cover today. Um, So there are two topics that we'll talk about today. The first one is the context caching, and the second one is the control generation. In fact, I'll start with the control generation, and then we'll go to the context caching part. Um, the context behind both of this is very interesting. This is something which has been, at least from a Gemini perspective, we have been very sort of soon in this developer. We had the context caching and the control generation from a very long time. We have seen developers using it to do amazing stuff with it. And these are the two things. So sort of let me at a high level mention what these two things are. So the first thing is the control generation. In fact, all my tabs are gone. Let me sort of open this up. So let's start with the control generation. Control generation essentially means that a lot of time we have been in a situation where you want your models to um, give the outputs in a specific format. And these specific formats can be JSON, it could be any kind of a dictionary list. So any data structure that you're sort of looking forward to is something what we call as control generation. What we essentially try to do in this is, and for example, let's say you have a prompt and you want the model to output in this specific structure, right? So this is what control generation means, where you can define the data structure of the output and the model sort of tries to force itself to produce in the same structure. So in this notebook, what we're going to do is, and again, I'm not somebody who sort of goes too much into the presentation. I prefer sort of showing you how things are done. All the code is available. Feel free to sort of replicate at your end, at your own use cases, and so on and so forth. So that's the control generation part, where we'll see how we can define different data structures into a prompt or as a schema separately and force the model to give outputs in those formats. And this is very, very crucial for, for example, building agents. So if you're trying to build any agent, you need sort of outputs in JSON or some data structure for the downstream processes to run um, efficiently and at scale in that sense, right? So that's the first thing that we'll talk about. The second thing, which is the context caching, is again very interesting, where many times, and this is the beauty of Gemini, because now you have 2 million context window, which means you can actually send a huge amount of context to the models. But the problem is, if you want to sort of keep asking it again and again, you have an issue with the pricing, because you're like, hey, I'm sending this context, which is, let's say, 1 million or something, again and again and again. It's expensive. It becomes expensive when you sort of suddenly scale this out. So it's as simple as saying that now you have a memory where you can actually persist your context, and then you can reuse them whenever you want them to be reused again and again. So these are the two topics that we'll go through in detail today. And when I say detail, I mean detail from a hands-on perspective, not sort of from a theory perspective. So see, we'll see different examples. Happy to discuss more examples of what you think about it and things like that. Um, Also, I want to be very clear with the fact that maybe these words are used differently in different ecosystem, like OpenAI, Claude, and all. They might use a different word for it. So, for example, control generation is structured output in the other world. So, one of the person was also asking the same question. So, it's exactly the same thing. They're named differently in the Google ecosystem. So, control generation essentially means that you're trying to get the structured output or some kind of a structure from the output, and we call this as control generation. Context caching, for example, in the prompt in the cloud AI world, they call it as prompt caching. They don't call it as context caching, but they all sort of they are trying to do the same thing. One thing which is very important is, and if I'll get time, I'll talk about those distinctions as well, which is every ecosystem. And when I say ecosystem, I mean there's one ecosystem which is Google AI, there's one ecosystem which is Vertex AI, which is part of Google Cloud, then there's ecosystem which is OpenAI, then there's ecosystem which is Anthropic, which is cloud models and all, cloud AI and all of that, sonnet models and stuff like that. So while the features are pretty similar across all the ecosystem, but there are sort of slight differences into how they have implemented it and their SDKs and things like that. So please spend some time understanding those differentiations among those different platforms. It's always going to be very helpful to any developers. So let's start with the control generation. Again, the notebooks are here. I've shared the link. If somebody has the link, they can keep sharing it in the chat. Both the notebooks are here. So let's start with the first one, which is the control generation. So it starts with a simple process where we install the SDK, Google Cloud AI Platform. I'm showing you examples of Vertex AI implementation of it, which is the Google Cloud implementation of the Gemini and the control generation. So Google AI implementation, which is the free versions outside of the cloud, is different, but the API sort of remains pretty much similar in that sense. So once I do that, what I essentially do is I sort of initiate the connection with the project ID, because again, I'm part of the cloud. So you need to make sure that you establish the Google Cloud connection. Once we do that, there are two things that you need to remember from a control generation perspective. One is that there are two models that we have in Gemini 1.5 Flash and Gemini 1.5 Pro. Both of them has a different way of doing control generation. So the way we do the generation which is controlled in 1.5 Flash models, again, for those of you who may not be aware of it, 1.5 Pro is a bigger model. It's more expensive. It's more useful when you have very complex scenarios that you're trying to do, or complex reasonings that you're trying to do. You would prefer using Gemini 1.5 Pro. So it's a bigger model. So which means the latencies are slightly higher. But if you're looking for very, very accurate or very, very complex reasoning, you would prefer 1.5 Pro. 1.5 Flash, on the other hand, is a faster model. So it's slightly lower model in terms of size. Um, the kind of generations and things that you can do is very comparable to 1.5 Pro, but it's faster. If you're trying to do something very simple, even slightly complex, 1.5 Flash would sort of be much better, because it'll be very fast for most of the use cases. So the way you do control generation is different in 1.5 Flash, which is you define the model. So you define the generative AI model, you define the model name, and then you define a generative config where you define that, hey, my response MIME type is application JSON. So the first thing that you define to the model, saying, hey, I'm expecting you to give me a response not in terms of text, but in terms of JSON. So that's the first thing that you define in the generation config. Generation config is the place where you also define the temperature, the top P, top K, and all of the other things. So this is one of the keys that you can define. So this basically tells the model that, hey, whatever the user is going to give me, the user is expecting some kind of a JSON to be given. Now, once you define that, the next thing that you do is you define a prompt. And in the prompt, you define the return of how you're expecting the things. Now, while we say application JSON, you can still sort of define many different kinds of data structures. So it may or may not be exactly as per the JSON, but it could be different. So for example, in this, I'm saying, hey, list a few popular cookie recipe using a JSON schema, and then you define the recipe, whatever the recipe is, and then you say, hey, please return this as a list, and each element of that list is a JSON format where the recipe name is there and it has to be a string. So once you define the prompt, that is when you sort of send this to a prompt. So you're not defining any specific schema at this point, which you're passing to the model. You're defining the schema inside the prompt, only mentioning to the model that, hey, I'm expecting you to give me the JSON output. Once you do that, and when you send this, you can see that you can now actually load the JSON just by using the JSON model, whatever the response that comes out of it. So we are not using the streaming, we are essentially using the non-streaming output here. So that's why we can just collect the whole thing, response.text, load this as a JSON, and then I'm printing this using a rich library, which sort of gives a better print than a normal print. And you can see that it actually follows that. So it gives me the list because I actually mentioned that the return should be a list. And then internally it says recipe name, and it gives me the recipe names as well, right? Now the thing is, you can see that there's a lot of things that you can innovate here, in a sense that you can go in details of this. As of now, I'm only collecting recipe name. You can see that it doesn't give me actual recipe. So you can define the schema. So this is where you have to be very careful, because you might ask a lot of things in your prompt, but then the schema that you're passing in the prompt doesn't even have those values. So for example, here I only have recipe name. That's why you can see that it only gives me recipe name, and it was not giving me the actual recipes of that recipe name, right? So for that, I can actually define that as part of my schema. I can say, hey, this is how the recipe name is. And then I can say, here's how I want you to give me the recipe, step by step recipe. And then you can define the structure, and then model will sort of try to um, answer you in that sort of sense, right? Sorry, I think I got disconnected.
That's fine. You are back.
I'm back, right?
Yes. Yeah.
My screen is visible?
Yes.
Okay, sorry about that. All right. So this is how you sort of do a simple generation, which is controlled in terms of the output from a Gemini 1.5 Flash models. Let's see how we can do this from a Gemini 1.5 Pro. Now, again, I started off by saying that remember that when you have to do very complex generations and all, you would prefer doing something like this with Gemini 1.5 Pro, because that's a bigger model. It can handle all those complexities and all of those things. So the change that happens in the 1.5 Pro from 1.5 Flash, which you can clearly observe, is that this time you have to give a response schema. Now, this response schema may look familiar to some of you if you have ever worked with Open API, not OpenAI. Open API schemas for and this is specifically 3.0 schema. So this is essentially how you can actually define a very core structure of the schema in a much better fashion compared to what we were doing in the Flash, right? So Flash was more straightforward. It doesn't require too much complexities in terms of how you're defining the schema and all. You can sort of just define a very basic schema. But if your schemas are very complex, if you're trying to sort of gather a lot of details and your schemas are nested and there's a lot of different kinds of data types and array objects and things like that, then you would need a model like Gemini 1.5 Pro, which is good at understanding that schema. In fact, it is also trained with Open API 3.0 schema as well, which is what you see in terms of the response schema. So what you see here is that, and in fact, I'll show you very very interesting way of getting to that. So I, just like many of the others, I was not very well aware of the Open API schema. So I was like, hey, if I want to do that, how can I learn this? How can I convert what I'm expecting to this kind of a schema? And I'll show an example in a moment of how you can come to this part, because this is what is expected in the model, which is 1.5. So let's see the example. The first thing is you again initiate the model name with the 1.5 probe. You define a schema in which you say, hey, the output is an array, which means it will have list, multiple list. Each list will have items. Each item will have a type object, and it will have the properties recipe name, which will be string. You also have to define the required parameter here, which is where you tell the model that, hey, I'm expecting all of these specific elements to be part of that structure. So once you define the response schema, and again, at this point, maybe a lot of you might be like, hey, I don't understand what you just did. The previous example was simpler. Just hang on with me. I'll show you how to get to this just by understanding what you need as an output, right? So let's say you have that schema. Once you have the schema, what you do is you again sort of do a response calling, which is model.generate content, in which you define the prompt saying list a few popular cookie recipes. At this time, you can see that we also have the recipe name. It's the same example that we did in the previous. This time we put this as a schema in a response schema variable. And then you can see that now what we're doing is we're doing the MIME type application JSON, which is exactly how we did in the Flash case. But this time we are actually passing the schema separately. So it's the schema is not part of the prompt anymore. It is actually the part of a separate variable that we are defining other than what we were doing previously, right? So that's the difference that we have. So when you actually run this, you can see again that it gave you pretty much exactly the same way that we got in the first case, which is you have a list, and then each list is a content. Sorry, each list is an element. Each element is a dictionary where you have the recipe name, and chocolate chip cookie is the name of that recipe. And you can see that we have defined that specific structure, and we have said that, hey, the final output will actually be array. So we are defining that. So when you actually again get this, you can actually load this as a JSON. And this is very like it's very trivial, but it's very important because what you're essentially doing here is that you're able to load this as a dictionary in Python, which means now you can do your logics, whatever the logic is. So you can say, okay, for each recipe, go and generate the detailed recipe and what will happen in this recipe versus the others and things like that. So this is what is very important in this sense, right? Okay, so having said that, now one of the big issues which a lot of people face with this is that, hey, I don't know a lot about the schema that you just wrote. This looks very alien to me. Is there any easy way, or is there a way where I can actually use LLM to actually give me this? And you would be right in thinking that what you need to know even to use LLM is the actual output that you're expecting. So let's say I don't know what the schema would look like. What I do know is that what the output would look like. So I know that I need a list. Each element of that list will look like a dictionary. At least this is something you should know. So you should not start with a blank saying, I don't know anything. I don't even know how the output would look like. I just want LLM to help me. Then in that case, you'll not be able to do this. So let me go to Google AI Studio just to show you one example where I can actually take just this. So this is Google AI Studio. This is free to everyone. This doesn't require cloud. And I can say, can you? And I'm just selecting any model that you have access to. So I'm selecting the latest experimental one, 1.5 Pro, and I'll say, can you give me a open API JSON structure for the following output type. Make sure that the schema is general and not adhering, not copying the example. Right. So again, I'm not giving you the best prompt. I'm just sort of showing you how you can actually just use LLM to give you exactly the same thing. So once you sort of put that, you can just optimize the prompt with your experiment. This is a very badly written prompt, so I'll just quickly run this, and you can see that it actually gave me a huge list of how the prompt should look like. And I can sort of keep asking and say, can you give a general version of this? Make sure you give JSON output. So what this will help me do is once I'm sort of clear with what is that I'm actually looking forward to, I can just get the whole schema from the LLMs in that sense, right? So this is how you can get the LLMs to actually help you get the actual schema for it. This notebook also has link to the documentation document. So if you're like, hey, I don't want to trust LLM to do that, I just want to learn this thing. I just want to learn how this is done. So the documentation sort of gives you that, um, gives you a way to learn and how to create your own schema by learning that. So this is a simple way where you can actually convert. And like I said, you should be aware, very well aware of what your output should look like, right? So what you should have is this, and then from here to here is very simple for you to reach. In fact, the other thing which I've seen a lot of developers do is that they take all of these examples that you have as an example. So let's say this notebook has like 4 or 5 examples. They use this as a few short examples saying, hey, here's a mapping of given a output, the schema, and can you please learn what these things are and then help me generate the response schema for one of the outputs that I have. So you can actually do few short examples in that sense, and you'll be able to get a lot of things. And that's really powerful. Like I've done this so many times. I don't know how to do this on my own. So what I essentially do is I just define the output structure, and then I just ask Gemini to give me the final schema. So let's see a couple of more examples. So this is another one where I'm essentially trying to generate a game character profile. So let's see the prompt, and then we'll try to see the schema that we have. So, oops. So the prompt here is generate a character profile for a video game, including characters' name, age, occupation, background names of their 3 children, and whether they can be controlled by the player. So again, if you see, the first thing is an array, which means we are expecting it to have multiple character profiles. So it's not just a single one. And then each element, so this is where it goes inside the items, is an object. Object essentially means that you're trying to get a dictionary coming out of it. So each dictionary will have an element of name. The type of that is string. The age should be integer. Occupation, background, playable, all of this we have anyway sort of defined here. And then children, and again remember it says that 3 children, so background names of their 3 children. So again in the children it says that, hey, the children will be array, which means that there can be 3 children, so that's why you need an array inside. Each array will again be an object. This is where you see the type object, and each children will have a name and an age. And you can see that required is again given both the directions, so you have required in both name and age, which means whenever the model is generating, it will make sure that it will generate the name and the age for all the 3 elements that you have. And finally, the required name, age, occupation, children for all the things. What you notice here is that it doesn't show playable and the background as required, which is what you'll see that when you actually generate the final thing, it doesn't include those 2 things specifically. So it's very important to define the required. If you do not define the required, then it will skip a couple of those which you have defined, right? So this is how you can actually define all of these things. Again, in this case, if you had an example of the output, LLMs would actually help you generate exactly the response schema that you need. And it's just a simple way of doing the same thing, which is you define the MIME type and then you pass the schema. Again, this is specific for 1.5 Pro. If you are somebody who's like, hey, I don't want to do all of this complexity, can is there, and I have a very simple structure that I'm trying to generate, then I would say please go to 1.5 flash, where you can actually define the schema in a very simple dictionary in a JSON way inside the prompt itself, so you don't have to do this complexity. Again, depends whether you're trying to generate a complex structure or a simple structure. So let me show you one more example. So this is, and again, there are 2 more which you can see when you get time. And then I'll pause for a moment, I'll take questions, and then we'll go to the context caching. So let's see this example. This is very interesting. This is one of my favorites. So let's see the prompt. The prompt says, analyze the following product reviews, output the sentiment classification, and give an explanation. So we are, so this is, this is interesting because this time we are also doing a classification. So it's not just we're trying to generate a data, but we're also sort of trying to do a classification in terms of ratings and all, right? So what we do is we say absolutely loved it, best ice cream I ever had, and rating is 4, flavor is this, and quite good, but a bit something. So you're giving a few short examples here. What you don't have here is any structure, right? So you have this as a simple thing, and then you define the structure. So first is you say this is a list, because again there are two different reviews that you have. Inside that, again, it's a list because you have a rating and the flavor and the sentiment, and the explanations of why that rating is given. So once you force feed that, you can see that how it sort of goes into detail. So first thing it tells you is that the explanation is this, sentiment is positive, rating is 4, and the strawberry cheesecake is this. So which means now you can actually use these two examples, and you can actually give, let's say, another new one, and you can actually do a classification where the output actually comes out in a proper structure that you have defined, which means you can actually leverage that in your downstream process. Let's say maybe this is a front end application where you want to showcase that. You can actually use exactly the same process where you can connect this with the front end or any other application. So this is, it is very powerful, and like I said, this is very powerful immediately, because you can connect this with any systems that you have, or you can connect this with any agents that you're building, because agents would require you to have a JSON structure or some kind of a structured data so that you can do all the downstream processing. Just to show you that this doesn't sort of only work with text, Gemini being the multimodal, which means it can accept images, videos, and all. You can actually do the same thing. For example, let's take an example where you have two images and you want a list of objects in the images, right? So just to show you what these images look like, this is just a normal image, and we're trying to do some kind of object classification, right? So again, what we have done is we've said we could have done this without that as well, and it could have just given us the objects, but we are like, no, 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 we want this in a proper structure. So we define an array, and each array should have a type object, which is essentially what the object is. And that's when you actually hit that, you can see that it actually goes into detail. It tells you all the objects that it sees on both the images, and that's how you sort of create a structured output of this, right? So with that, I'll take a pause. I'll stop here before we jump to the next topic, and let me address some questions on this quickly. Um, is there a way to see the prompt that arrives to the LLM? This is nice abstraction. It's helpful to understand the form. I think, Omar, if I understand your question, you're looking you're looking for the system prompt, right? For doing the extraction, if that's what you're looking for. As far as I know, the structure output is not new. You have like merge and controls better, or what weakness of structure? Yes, Kaho, if your question is whether this is new or old, again, I'm not saying this is something that you have in Gemini or something. But all I can say is that based on my experience having used different ecosystem, I am pretty confident with the Gemini one. So feel free to use it. Let us know if there's something that doesn't work the way you intended, and we'll be happy to sort of work and make it better. Does every form of structure, the definition that we presented, have to be stored in GitHub, or if this is dynamic? Um, oops, sorry. So, Timothy question is, does every form structure, the definition that you have presented, have to be stored in GitHub, or is it is actually dynamic? So you don't have to store, as in dynamic in a sense that whenever you're doing the generation, you can actually pass whatever your schema is, and those schemas can actually be generated on the fly. So you can very well do those things as well. You can specify Python class its response schema that will be much easier to understand. Yes, you can do that as well. There are some examples in the documentation where you can do that as well. I think I have a case where I prompt the model of thing and then output the result in a JSON. Only after I thought about it, I've been so. That's a good one, which is so Lonnie is saying. I think the model essentially does a chain of thought reasoning kind of a thing in the back end before doing that. Yes, I think that's a good practice if you want this to sort of have almost like a meta thinking or um, internal monologue. So I would say that that will be a good one. This doesn't do that. It's trained to sort of give you the output. It's very reliable. Another question which somebody was asking. So I would say that it's very, very reliable. And then, at least in most of the use cases and the systems that I've built, especially for the LLM ops perspective, when we are trying to build those pipelines, it's sort of very, very reliable in that sense, especially the 1.5 Pro. So as long as you can define the schemas very well, it sort of does that. Also, which is very important, which we have figured out in our experimentation, is that you have to be really you have to really be a good architect at defining the schema. A lot of time I've seen people defining the schema, and I'm not specifically talking about Gemini or any XYZ model. I'm saying this in a very blanket and a general statement. Many times I've seen people defining schemas where they are taking values which are very static values, so they are not something that are part of the generation, that are part of something else, maybe the context or something that they're passing. They also include that in part of the schema. So what then happens is that you see a lot of hallucination again across all the models that you have. So you need to be a very good architect of the schemas that you're building. The schema should be very specific to the generation. It should not have things which are part of the outside of the context. So if, let's say you're using a page and you're saying, hey, also include the page number and all, which is also part of the context, then in that case, this will not work very well with any of the model. You'll always have chances of hallucination in those cases. So be very clear with it, be very good at architecting the schemas, and this comes with experience. So the more you architect those schemas, the more you'll understand the goods and the bads with respect to the model. Okay, so having said that, let's sort of go to let's go to the context caching, which is again a very interesting topic. Again, I might have missed some of the questions. Happy to take those questions toward the end of the session, where you can actually raise your hand and ask those questions, so that we can complete the things that we want to do today, and then we can go in detail of anything which I've missed so far. Um, the other thing is, if you want to sort of explore more examples, I'll also quickly share this in the group. This is, again, like I said, there are two ecosystems in Google. One is Google for AI, which is Google AI ecosystem. Most of it is free. You can just use a Google account and you'll be able to access all the models and everything. There's a cookbook associated with this where you'll have many different examples of how people have used that and how you can build things around it. So this is the cookbook for it. I'll also share the cookbook for cloud in a moment once we go through context caching. And again, if you would have forgotten, we are using the Gemini API from a Google Cloud perspective, not the open Google AI perspective, right? So just be clear, because those two ecosystems are slightly different. They behave different. The API signatures remain pretty much similar most of the time, but the underground backend sort of is very different. Okay, so let's see the next example, and this example is very interesting because what we talk about in this is essentially caching a big context. This happens because now we have models which are crossing millions and 2 millions of the context, especially Gemini, where you have 2 million contexts available to developers now, which means you end up sort of sending the same thing again and again, and it would not be good on your budget, because you'll sort of end up spending $7 or $6 if you were to sort of go through all the 2 million and 1 million, right? So we'll see two things. We'll see how do you cache the context, like from a very basic perspective, and then we'll also see a RAG example, which is one of my favorite, where you'll see how we can actually use context caching to make our RAGs much better. Now, again, I want to preface this by saying Context caching is nothing new. There are many models where you have context caching. There are very different ways people have done this. Companies have done this. The way Gemini does this, or the way Google does this, is slightly different because we are aware that there are use cases where people are going to use 1 million and 2 million context. So all of what we are going to do is based on that, where you're able to send let's say 2 or 3 documents at one go, rather than sort of sending the small chunks of it in one go, and you're able to sort of cache all of this, right? So let's see how we can cache something. So the first thing we do is we define the model ID, which is 1.5 Pro. You can actually do caching with both 1.5 Pro as well as 1.5 Flash. Um, Once you do that, you define the system instruction. So what you see here is a very simple way of defining it. So I have a system instruction where I have these two files, and these two are essentially research papers. So one of them is a Gemini um, technical guide, and the other one is the Gemini 1.5 paper. So just to show you, this is roughly, I think, 100 pages, if I'm not wrong. Just let's see. This is, yes, so you can see that this is almost 90 pages. Then this one is, so one is Gemini, the initial one, and the second one is Gemini 1.5 thing. This is also, I think, actually more than 100. So this is close to almost 154 pages. So net in net, you have 250 pages, 200, 250 pages. Now, again, understand that you may have a lot of questions with this document, right? And with Gemini, because you have big context window, you can actually send the whole document as is and start asking the question. Then why do we care about caching it? Because you can't sort of send the token again and again. You can't send the cache again. You can't send the document again and again, because you'll end up sort of putting too much cost into that. So what we're doing here is we're saying, okay, please take both of these document, which is roughly 200, 250 pages. You put a system instruction based on whatever you're trying to do by the end of it, and then you use caching. So we have imported caching. You can see that we are sort of importing cache somewhere. So you can see that we are importing caching. For that, we are using the cache content. We create this, we define the model ID, we define the system instruction, the content, which where we have the URI. The other important thing is that both of these PDF, you can see that they are currently being hosted on cloud storage. So if you see the GCS, this is basically mean that Google Cloud Storage, which means that they are in GCS URI, and which is what we are passing. So we don't have to download anything. This is already in cloud, which means it's very secure. Nothing is being downloaded. Nothing is being going anywhere. All the processing is happening in your project ID in the secure environment that you have. So this is very, very interesting. And this is why we have these two ecosystem, right? The one where you do experiments, where you don't have any official documents or company documents, but in the cloud environment, you can do all of this very easily because nothing goes out from your project ID. So once you do that, the one very important thing that you have here is the TTL time, which is how much do you want this to be cached for. Do remember the pricing, and you have to look into the pricing for the caching. I've given the link in this notebook. You have a link of the documentation and the pricing. What you have to be careful is that there is a cost associated with caching per hour. So if you're caching, let's say 1 million contacts, then you have to pay per hour based pricing. This is why it is important for you to architect the solution in a way where you say, oh, I need this caching in maybe, let's say, in the net of 5 hours or 6 hours or 1 hour. And that's the time that you can define. So that is the first thing that you need to be careful. So you do this, and because I'm running this right now, I'll say I don't need this more than 60 minutes, right? So I'll just keep this as 60 minutes, which means up until 60 minutes, I can use the cache content, and I can keep on sort of using this again and again. So once I implement this, what I can then do is I can simply now load the model. When I load the model, this time I can use from cached content. So what is happening right now is that whatever I have cached, I can use that object. So you can see that this is the same object that I have used here, which is the cache content, where I've saved both the files. I can simply load this. So this is faster than sending this again and again every time. It'll just load this KV cache into the memory, or it'll just point to that KV cache where you have saved your own file. And then you can just keep on asking the question. You can say, hey, what is the research goal shared by these research papers? And it'll just give you the answer directly. You can also sort of do a chat, which is more back and forth. So rather than doing one off conversation, you can also sort of start a chat saying, and you can go back and forth with whatever the answer comes out. But all of this is happening from that cache perspective. So this is not like you're sending that document again and again. So this is very powerful from those use case perspective. And this, the use cases people are able to build with this is again amazing. The kind of things that we are seeing developers and companies building is is great. The other thing is you can actually refresh, or you can actually delete the cache. So you can refresh in a sense that, let's say you are already at 60 minute, and you're like, hey, I want to sort of refresh this so that this doesn't gets deleted. So you can refresh it so that it still maintains the context, or you can actually delete it on your own so that you're very careful that, hey, I'm not going to spend more money than I need the context to be there. So this is the very basic of how you can actually delete the context. There's a lot of things you can go into the documentation and look into and see how you can update the context if you were to do that, and so on and so forth. But I want to show you one very interesting example of how you can use something like context caching and do RAG in a very different way. So this is my take of how you can use context caching in a RAG environment. So let's assume you have these 5 files, right? And you want to ask a very simple question. So I have written a very simple RAG, where what I do is I go through each document, I split each page, and then I extract the text from those pages. And I then do the embeddings from each pages, which is what you can see here. And once I have this, I write a very simple function which does a simple RAG, where it takes the question. So this is my question, where how does Alphabet organize structure aim to balance innovation with financial stability? So what this is going to do is it's going to do embeddings. It's going to find the top chunks or top page where the answer is available based on the embeddings that we have. And then it'll try to answer from that. So when I run this, you can see that it actually gives me the answer. Um, I had the citations and everything because I'm sort of storing all of this. So this is like your typical RAG. Like again, there's nothing new that I'm doing here. This is like your typical RAG based on the 5 documents that you have. But let's see how would this change when you actually have something like context caching, because let's try to understand what is the problem with this, right? This is the same thing that we have seen again and again with RAG, where because you're splitting everything by pages, you may sometime miss the context of the previous page or the pages 5 down, and it might not give you a very relevant context because of the similarity or the cosine similarities that you're using. So all of this really restricts RAG, because then you have to build many other kinds of patterns of RAG, like graph RAG, C RAGs, and all of those RAG, which sort of really addresses those shortcomings. But with context caching, actually, you can go a little further, because, like, again, remember the benefit of using Gemini is that you have that 1 million and 2 million, right? And if you notice, we're not actually using that even in the normal RAG, because all we are doing is we are doing top five, which is the top five that we are taking, which is not even taking care of the 1 million context that we have, right? So let's see how we can actually use both the 1 million, 2 million capacity as well as the context caching to actually make this as a much better implementation of RAG. And this is more like a context caching RAG, right? So we start with the same 5 files that we had. We define a systems instruction this time, and we say, hey, you're a helpful assistant. You have 10K filings, and blah blah blah. So you define some guidelines of what it needs to do. What I then do is I essentially, and again, one thing which is very important to remember is that the minimum token count that you need for caching is 32,000. So if for whatever reason you're trying to cache anything less than 32,000 tokens, you will not be able to do that. So it has to be greater than 32,000. So what I do here is I create two different cache. I create file 1 and 2. So I split this in file 1 and 2, which is one of my cache. and then the other cache is file 3, 4, and 5. No reason whatsoever. This is just a simple example. You can define your own combination. One of the reason why I did this too split is because I want to be greater than the 32,000 tokens. The files that I have are sort of 40 pages, 50 pages. So if I were to do single file, it sort of fails because I have that 32,000 token issue with that, right? So what I do is I combine file 1 and file 2 into this caching, and then I have file 3, 4, and 5 into this caching. So what this does is I now have two caches that I've created. Each of them represents different set of files, and both of them are greater than 32,000 tokens, and they're sort of in the 1 million side of things, right? The next thing that I do is I do a cache mapping. So with each file, so if I know, for example, if I'm asking a question and I know that the answer, high probability of getting that answer is available in a specific document, I have a mapping of where the cache is available for it, right? So this is like as simple as doing simple any kind of memory mapping or memory cache mapping and things like that, right? So now I do the similar thing that I did previously, but this time, once I know the citation of where the answer is available, I take the file name, the top file name where the representation is, I load that cache, and then I ask the same question back to the cache rather than doing the RAG pattern. This time I'm getting the cache of that document. So I'm essentially passing the whole set of documents where the answer is. So this is very different from normal RAG. Why? Because in the normal RAG, you actually just have those chunks that you pass. This time, I'm actually passing the whole set of documents. Let me show you how sort of it changes the outputs of it. So I have the same question again. I don't change the question. I now call this, I do top N3. So I'm just saying wherever the top three is. And it tells me that, hey, this is the file where your answer is. And see how now, because it has huge context in itself, it changes the whole answer in a much more detailed fashion. So it goes into details of things, it goes and sort of tries to answer it because now it has more than 100, 200 pages which it can refer to. And it can give me a much better answer compared to what you see before. So this is the answer before. Now, just to be very clear, it's not that the first answer was wrong. It was correct, but it didn't go in detail of expressive way of answering the whole question. And that's the difference that you notice with the context caching with the RAG. So that's how you can sort of use something like context caching. And again, this is a very, very simple example. You can sort of imagine the complexities that you can do with this at this scale. With that, right on time, I'm going to stop and let's take questions. It's very hard to read questions from the chat. So, what I would request is you can just raise your hand and let's address the question live. All the questions of the control generation as well as context caching. Happy to address them live.
Great. So, yeah, so if you have questions, and please raise your hand, and I will unmute you. You can ask questions.
Please raise your hand and you can go step by step. So, Bill, you can unmute. I think a couple of people have
Oh,
Yes.
raised
okay.
hands.
Go ahead, Raymond.
Yeah, thank you for this. This is really interesting. How did you come across this approach of the caching? Is this something that's been around for a while? The context caching?
Yes, so context caching has been there. With Gemini, it has been there for a longer time. I'm not, I'm not 100% sure if this was there with OpenAI, but Anthropic has prompt caching, which they recently released. So it has been there. We've been playing with this almost for a month now, more than a month actually. So yeah.
And it sounds, and so it really comes into play with the larger context windows, right? Or
Yes.
right, because you don't really need it with the smaller ones, or would you use it with a small context window?
You're right. You're absolutely right. Like it would not make a lot of sense if you're using this with a small context. This is very useful from a Gemini perspective, both from a multimodal perspective. So let's say if you have 1 hour video that you're trying to analyze or ask question, it would make a huge bill if you were to just sort of keep sending that video again and again. Not just the cost, but it'll also create a lot of latency, right? Because every time you're sending, it has to reprocess the KV cache, so it'll wait for like 30 seconds, 40 seconds just to understand and answer your question. Now, cut to caching, both of this is addressed. So one is you can keep the cache, let's say for next 1 hour, and then you can continue to ask questions without that latency of rereading again and again and creating that KV cache. And the second is the cost is much lesser than sending again and again. Like you can actually compare if you go to the costing page. If I were to send that 1 hour video every time, let's assume that that's like 2 million or 1 million context, it'll cost you $6 to keep sending this again and again, versus if you were to just cache it, which will be like very very cheap, and you can ask like 10 questions on the fly, almost very cheap. So I hope that makes sense.
That's awesome. Thank you.
Yep, thank you so much.
All right, the next one is Danush. Sorry if I say your name incorrectly. So you are next one.
Go ahead, Danush.
All right, so let's go with the next one. Lonnie Chris.
Yeah. Okay. So I'm going back to the control generation.
Go. Yes, I'm back to that.
Sorry, Lonnie, can you unmute yourself again? I just accidentally misclick.
Okay.
Sorry.
Okay.
Say it again.
Okay. Okay. So I'm going back to that question I had about thinking and then generating a control generation, a controlled schema. So the issue is that when I think when I say use a schema, it applies to the entire response. And so my question is, when I want it to think, before it starts generating the structured response, I don't want it, basically the schema, I only want it to apply to the structured response part. So I was just wondering how you recommend doing that. I mean, I could make the think part of the schema, but I'm just kind of afraid that if it jumps into doing the schema before it's done thinking, it might not, think it through well. So.
Right. So I think that's a very fascinating thing. In fact, I'll give you an example where I've used something very similar for doing the RAG generation. So just like we do a normal RAG, I did something very similar where I said, hey, before even answering based on the context that you do, can you do a process of thinking, or let's say meta thinking, where you actually go into detail of what is the question, what is that exactly I'm asking, does the context really answers that, are there any elements that I'm missing? So almost like how a human would think. That really changes the output of that RAG. Like if you just add um, uh, a single layer of chain of thought reasoning before doing RAG, it really changes the answer in a good way. So taking that as an example, I would say definitely what you're thinking is right. However, please make sure that when you do that experiment, because I don't have an answer to say whether that will really give you the benefit that you're looking forward to. So what I would say is that do it in a machine learning way where you set up your experiment. So you say, hey, here are 5 things that I want to generate a schema for. Here's what I'm expecting it to do. So you define your ground truth or ground cases, then do it without the thought process, the thinking process that you're thinking, and then do it with the thinking process, and then measure both the latency and how accurate the results are. I think that is the best way for you to know. Like just like in the case I was mentioning, I actually had all of those details so that I can actually make a comparison and say that, oh, this is really helpful, even though it takes a slightly higher latency because I'm sort of adding one more step. But the answers that I'm getting are so good that I'm okay to let go of that latency. So you have to do the same analysis with your thing. Does that make sense, Lonnie?
Yeah, I mean, I'm convinced in my case the thinking part is having a strong benefit, but the problem is that because I can't put the whole thing into a single schema. The actual JSON that gets emitted, when I put it into one prompt, isn't always in the schema that I want. So, it seems like to use the structured schema, you have to say the entire response is going to be in this schema. I mean, I suppose I could say, I could like say the think output is part of the schema, right? And then then the whole response is in one schema. But I'm just afraid that I don't know. I mean, you may question whether it's going to affect the quality if the thought process is inside the JSON or not. But anyway, I was just wondering if there's a way to say just the JSON part should be in the schema, not the whole response.
Yeah, and I think this is where you can leverage the 1 million and the 2 million context input that we have, at least from a Gemini perspective. And again, I don't have a final answer on it because I've not done that personally.
Yeah.
But I genuinely think that if you were to leverage, forget for a moment that there is something called control generation, like assume that you have just the raw Gemini with 1 million. How would you then create a prompt with few short examples and leverage the 1 million input that you have? Because we've seen where we've given like the whole code repository and it was able to do a lot of crazy things that we are still sort of sometimes baffled with. So I'm assuming that will happen in your case as well. So I would say explore this and see where it goes.
Okay, thank you.
All right, thanks. Let's take the next one. Next question.
Hey, John Kim. Yeah, you're next.
Yes. Thank you. So I just have a question in the code from the context caching notebook, where in the get answer with context cache function, they're like, because I see that in the cache mapping, the first, as you shown, like the first and second files are kind of redundant mapping, and the third, fourth, and fifth are also the same. So I was wondering, like, if it's okay to like repeat the tokens in the cache, and whether there's like any maximum tokens you can cache. If that makes sense.
Yeah,
Like,
I think that's a good question. That's a good question. So, if you remember, I said that I'm actually combining both the files together in one go because if I do single file, the caching fails because I have to maintain the 32,000 tokens. So there is a minimum that you have to address, which is the 32,000 token. The maximum is 1 million token, which is 1 million or 2 million token, whichever model you're using. But the minimum has to be addressed in that sense, right? So that's why I actually combined both of them together. And in this case, I combined three of them. And this should be absolutely fine. There's no, it'll not create any confusion or anything. It's just that as long as I know that it is any of these three files that will address my answer, I will just load this caching, which is the same caching where all the three files are there, and it should be fine. Does that make sense?
so it would be better to just kind of specify all those 5 files instead of 2 unique files. That would be better. This way would be better, right?
This way would be better because and actually there's a star mark there. It's a very good observation that you have, because see, if for whatever reason your individual files have 32,000 tokens, because sometimes you do have files which are like 1,000 pages in itself, in that case this will not happen, right? Then you'll actually have individual caching for each of those files, because you'll cross 32,000 token minimum requirement in that case. So in that case, you'll have all the unique caches for all the unique 5 files. My problem was that my files were very small, so I had to combine them together to form a single file, and that's absolutely fine. Like, it doesn't affect the output, but I had to do that because I had the smaller one.
Okay, makes sense. And also, like, is 60 minutes kind of like conventionally like default time limit? Like, is there a reason why it's 60 minutes?
Yeah, because the
Uh,
pricing is dependent on 1 hour. So if you see the pricing, it is per hour basis, almost like storage. So because you're using the storage for the KV cache, it is the cost is per hour. So that's why the minimum is 60 minutes, and then you can do the multiples of that.
Thank you.
Okay, let's take Vishal's question, and then I think Dhanush also has a question. We'll take these two, and then I have to drop.
Yeah, hi Lavi. So my question is, does this 32768 include, actually I have three questions. I'll club them into one. So first question is, does this 32768 include the document as well as the prompt that we are sending? This is the first question that I have. Would you like to answer this and then I move on to the next one?
Oh yeah, yeah. Quickly, I can answer that. So this only includes the system instruction and the file. So in fact, if you see the calling of that, we are only passing the system instruction and the content, which is the whole document. So not the prompt, as in the question that you asked later. So that's separate.
No, yeah.
Make sense?
So I think this is the same as all the other. Yeah. Um, can I go ahead with the second question?
Yeah, yeah. Go ahead. Go ahead.
Yeah. Yeah. So what about RAG for CSV files? A lot of structured data also appears in PDFs. Many tables do also come, and there are even sometimes images.
Mhm.
So, what is your take on that in terms of context caching as well as normal RAG? Like, how do we make it more efficient in those cases?
That's a very interesting question. So I actually have a notebook, and I'll share the link, Vishal, in a moment, which is how do you do RAG with Gemini when you have video. In fact, it goes beyond just images and text, but it also has video and the audio input. Um, in fact, if you see my GitHub, there's a IO talk that I have folder in which you'll see that RAG functioning. But just to address this from a context caching perspective, this is very new. I've not really explored from a context caching perspective, but how I would think about this is that as long as you can cache the modalities, which is the images, video, audio, and PDF, it should be same as what I have shown you. That is one. Second, um, I think the other question which you had was the long context one. Can you repeat that question? Sorry, I missed that part. There was one more that you had.
Yeah, so I just wanted to ask about how the context caching will handle this when structured data is present.
Right. So the structured data, see, it's like, oh yeah, what I wanted to mention is that when you actually upload the PDF, right? So when you do the context caching or when you load this, so when you define the MIME type application PDF, it actually takes this as an image, not as the text. So what benefits that provides you while doing tables and images and all is that now Gemini can actually give you much better responses because it has learned to interpret charts, it has learned to interpret tables from an image, not from the text. So it is far better than doing this from the image perspective. Having said that, it is not 100%. In a lot of cases that we have seen when you have complex tables and all, Gemini sort of not just Gemini, like most of the models, if you were to send an image, it will falter. So the combination that would work in that case is that as much as structure that you can extract as a precursor, doing your pipeline of the RAG, you do this doing this would be much more beneficial. And along with doing this application PDF where it is taking this as an image. So the hybrid of that would work if you want to scale that up. Does that make sense?
Yeah, yeah, it made sense to some extent, but I'm still not clear on how tables, like you are saying the tables will be cached as images.
Correct. Not like it's not extracting tables separately. Think of this as if you have a 10-page PDF, each page is saved as an image. And when you ask a question, Gemini has been trained to address that. If the answer is available in table, it will know how to extract that from the image, not from the table. So there's no second process which is happening in the back where it's extracting the table as a data frame and then it's trying to answer. Does that make sense? So that's why
Yeah.
it's better than the text. Now, and again, that's why I said the star mark there is it's not 100%. So if you do a lot of experiments, out of that experiment you'll see that, oh, it did answer me a couple of things, but there are a lot of things where it did miss due to some issues here and there. And that's where I said that for those you do the hybrid, so you extract all your tables, images, and everything extra, using a lot of pre-processing that we have, many libraries and many closed source projects, and then you sort of combine this with that.
Okay. Okay, got it. And my last question is, what do you prefer, the graph rag or context caching?
They both are separate. So graph rag you would anyway have to do because it depends on the kind of questions that you're asking. So if your questions are very factual related questions, like, hey, what's the revenue, what's this, what's that, like if you're essentially asking a very entity driven questions, graph rag would always be much better, costly upfront, but later you'll have much better answers. Context caching is essentially um, you know going to be useful when you're trying to do um, um, something which is not something which is more reasoning driven, which is to say you're trying to compare 5, 7, 6 different entities that, oh, this happened, then this happened, then didn't happen, what do you think would be the final result of this? That is when the context hashing will be very helpful. Does that make sense?
Yeah, because cost-wise, I'm asking which should be more efficient because GraphRag is a bit costlier uh, from what I've experienced.
It is expensive because you are essentially doing a pre-processing layer and then storing those graphs as well, right? So yes, it will be expensive, but then again, it what I was telling Lonnie as well, which is as a ML guy, you would have to define your experiments and measure all of these things and then make your trade-offs, right? Like if graph makes more if graph becomes more expensive for you to scale, then you go back and see what's the non cost way of doing the same thing, and you define that by the questions that you have in the system.